Great. I think we can start now. So good afternoon, everybody. As I told you last time, on Thursday, we are going to have a lab on RTI and IRQ interrupts. Okay. This lab should be very easy, just a modification to one of the programs I taught in the lectures. Okay. Today, I'm going to start timer functions. So just give me 1 second. Okay. So guys, in the first lectures, I told you we have a microcontroller, right? Our microcontroller, I told you, it is a complete system, right? And inside the system, there are different circuits, right? So I told you inside the microcontroller here, we have timer system. It's a circuit. It has analog to digital converter. Also, it has serial communication and other stuff. So it has a lot of circuits, right? For sure, we don't have time to teach all of them. So in this lecture and next lecture, I'm going to focus on the timer system. Okay. However, the good thing is, if you understand what I taught so far, as you will see right now in the timer system, nothing is new. I'm gonna use interrupts similar to what I did in chapter 4. So that means if you want to learn any other topics, advanced topics, it's going to be very easy for you because nothing is new. We just use the same way or to program interrupts to manipulate registers, as you will see right now in the timer system. Okay. So let's see. So as you see here in this picture, guys, our microcontroller has, I told you, timer system. As you see here in this picture, our timer system has 80 channels, as you see here, starting from channel 0 up until channel 7. Okay, 80 channels. Every channel, as you see here, let me use laser. Sorry. So as you see here, every channel can function as input capture or output compare. Is that okay? So I'm going to explain later what do you mean by input capture or output compare. But for now, input capture and output compare are two functions. Okay, every channel can do one of them. So every channel you can program every channel to do input capture or to do output compare. I'm going to tell you what is the difference between them. This is number one, right? But this is something programmable. You can program. That means you can use all of them input capture or you can use all of them output compare. However, you cannot use one channel input capture, output compare at the same time. You cannot do that. You have to select either input capture or output compare at a certain time, but you can reprogram it if you want later. Okay. Also, as you see here, every channel has a pin, external pin in port T. So you have here, this is a pin in port BT0, BT1, BT2, and so on. Okay. You can see also every channel here from these 80 channels can trigger interrupts. That's why you see here a channel 0 interrupts, a channel 1 interrupts, a channel 2 interrupts until a channel 7 interrupts. So now we're going to have 8 more sources of interrupts. Every channel can trigger interrupt. Why? I'm going to give you details later. Okay. Also, you can see here we have a counter. We have 16-bit counter. Okay. And then even this counter can also trigger interrupts. We call it timer overflow interrupts. Okay. So this is just a big picture. Now I'm going to give you the details. Okay, guys. So let me summarize what I said quickly before I give you the details. We have a timer system. This timer system has 80 channels. Every channel can be programmed as input capture or output compare. Every channel has one external pin on port T, right? And we have a 16-bit counter, right? Also, we have 9 interrupts. So we have one interrupt can come from any channel, right? And also one interrupt can come from the counter. We call it timer overflow interrupt. And we're going to talk about all of that. Okay. Now this is a big picture. Now let's go to the details. Okay, guys, any questions? Details. Now let's go to the details. Let's start with I'm going to start with the counter. I told you we have 16-bit counter. So what this counter is doing? And also don't be confused, please. We have 80 channel, but we have only one counter for all of them. So we don't have 8 counters. We have only one, right? This one is used for all of them. Okay. So let's see what this counter is doing. Number one, I told you this is 16-bit. As you see here, guys, this is counter. What this counter is doing, just counting. Okay, I'm going to tell you why. For sure, there's a reason, but this is how it works. So the counter should count from 0, 0, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on until 1, 1, 1, 1, 1, right? And then after 1, 1, 1, 1 is gonna rule is gonna go to 0, 0, 0, 0, guys, and repeat again. So it's gonna count from 0, 0, 0, 0 until 1, 1, 1, 1, 1. Okay, and then repeat again, right? So all the time, this counter should count from all zeros to all ones, and then all zeros, all ones keep counting this way. Why? I'm gonna tell you later why, but just let me finish this part. Also, you can see here what we call timer overflow interrupts. You can tell from the English name overflow, right? Because actually, when the counter is 1, 1, 1, 1, and then after 1, 1, 1, it's gonna be 0, 0, 0. At this time, we call it overflow happened, right? So anti-trigger interrupt at this time. So every time the timer rules from 1, 1, 1, 1 to 0, 0, 0, actually it's gonna trigger interrupt as you see here, and this is what we call timer overflow interrupt. Is that okay? So the other thing I wanna talk about is the speed of counting. This speed of counting. Okay, how it works? I'm gonna tell you how it works. Very simple. Look here, guys. So this is a counter. This counter, I'm gonna input here a clock square wave, right? A square wave this way, right? And I can control the speed of counting. I can control the speed of counting, right? How? Because actually every cycle here, the counter is gonna increment it by 1. So for every cycle, it's gonna be incremented by 1. That means the frequency. So the higher the frequency of this clock, the higher the frequency, the faster the counter is gonna count. Is that okay? So that's why if you see here, I'm telling you here, the time from here to here is 1 over f, right? F is the frequency. That means it's gonna take from here to here. It's gonna take time 1 over f, 1 over f, 1 over f, and 1 over f. That means we can control the speed of counting by changing the value of f. Right? So what is f? How can we get this clock? Okay, how can we get this clock? It's explained here. So this clock actually, guys, is our e clock, which system clock, which is 24 megahertz. Okay, and then we divide this one by what we call prescale, right? And this will be the clock of the timer or the counter. Okay, so again, this one is fixed 24 megahertz. All what you can do, you can just program the prescale here. You can program it. Is that okay? In order to control the frequency. And by controlling the frequency, you can actually control the speed of counting. Is that okay, guys? Any questions? Okay. So how can you control the prescale, guys? I can control the prescale easily, as I'm going to explain later. I just want to skip it. I want to show what I mean. Yes, we have a register, this register, right? All what you have to do, we have 3 bits for prescale here, 3 bits, right? So if you put here 0, 0, 0, you actually, the prescale is 1. So that means it's going to be 24 megahertz divided by 1. Okay, so that means this is the fastest speed, right? It's very fast, right? And then if you put here 1, so you are going to divide by 2. So actually it is always 2 to I, and this number is I, right? So here 1 should be 2. If it is 2, actually you get 4. If it is 3, you get 8, and so on. So that's what I'm saying. All what you have to do, guys, just 3-bit. You can 3-bit in this register here. All what you have to do, the number you put here in this 3-bit, you can control the speed of counting. Okay. Okay. Again, I didn't explain yet why why you have something counting here, right? But you can guess. I didn't say yet why, but you can guess. Actually, this counter is going to be needed for input capture and output compare, right? So this counter should help input capture to do its job or its task, right? Also, it's going to help output compare to do its functionality, as you will see right now. Okay. Any question, guys, before I continue? Again, I'm repeating it for the second time, guys, because maybe a little bit confuse some students. Okay, so what I'm saying, we have 8 channels, but we have only one counter, not 8, right? This counter is used by all of them, right? Okay. And this counter, all the time it's counting. As long as you enable it, as long as it is enabled, it's just counting, as you see here. And you can control the speed of counting. Great. Now, I'm going to talk about, I told you, every channel can act as input capture or output compare. So tell us, what is input capture? What do you mean by input capture? And why it is interesting, why it is useful? I'm going to tell you why, okay? So look here, guys. Let me explain it here very easily. Look here. Before I give you the details, I want to tell you, so here's the timer system can help you to do input capture or output compare. So what this means, I'm going to tell you what this means. Look here. In many application, guys, I have a signal, something like that in many application, and I want to measure the time here. I want to measure this time, okay? Or you have something like that, guys, signal like that, and I want to measure the time from here to here, right? What is the time for some reason, okay? So many application, we need to measure the time, something like that, okay? Not only that, for example, you have a signal coming from somewhere, and also you have another signal coming from somewhere, and you wanna measure the time difference here, right? Because this time difference can mean something, right? And you can use it for something. Okay, so there are many applications we need to measure time, like something like this one here, something like this one, something like this one. Is that okay? I'm gonna give you only one application for now, right? And then I'm gonna continue. But let me give you one application why sometimes I want to measure time, right? So I'm gonna go in the slides here. I have nice picture. Let me go back. Where is a nice picture? Where is a nice picture? Where is a nice picture? Yes, it's here. Look, guys, this is ultrasound sensor, ultrasonic sensor. Yeah, this sensor, it's ultrasonic sensor. This is a very popular sensor, right? It is used to measure distance. Robots usually use it to measure distance. Okay, the distance for example, this may be a robot, and I want to measure the distance from here to the object, the nearest object to me, right? So as you see here, guys, it has two parts, two pieces. One piece is transmitter, one piece is receiver. Is that okay? I'm going to tell you how it works. It's very simple. I'm going to tell you how it works. Very simple. Look here, guys. So as I told you, it has two pieces. One is transmitter and one is receiver, as you see here, right? So once, if you want to measure distance, right? So what happens is you have to generate this signal this way, and you have to put it on the transmitter. Okay, is that okay? Once you do that, once you generate a signal this way and put it on the pin of the transmitter is going to send ultrasound, as you see here, sonic or ultrasonic sound, right? And then when this sound hit, and also at the same time when it sends the ultrasonic sound, this pin is going to be high, as you see here, high. So at the same time we send this a signal, this one become high, as you see here. Okay, guys? And then this sound should hit an object and should come back to here. Once this one come back to here, this signal will be low. Right? Again, let me say it again. Very simple. So number one, you have to generate a pulse like this way. This way, you have to put it on the transmitter. Once you do that, the transmitter is going to transmit ultrasonic sound. This sound is, and also is going to raise this one high, right? And then once this sound hit an object and come back, once the receiver receive it, this one will become low. This one actually is here, right? On this pin, right? So if I can measure the time from here to here, if I can measure this time, this is actually the time for the signal to go and come back, right? To go and come back. So actually, if I can get this time, I'm gonna call it t, and then I'm gonna divide this time by 2. Why you divide by 2? Just to go, right? Because I want to measure the distance from here to here. I want to measure the distance from here to here, right? So that's why I divided by 2, because this time is to go and come back, right? Now I have a time, right? So I have the time for the signal to go, right? Now you have a formula. You have a velocity, speed, or it's a speed. Sorry, the speed should equal distance divided by time, right? Time. I already measured the time, so I can plug in the time here. The speed is known because this is the speed of sound, right? So it has a fixed value. Let me remember. I think it's 333 meter per second. You can search for it, but this is a fixed value. By this way, the only unknown here in this equation is the distance d, so you can calculate d. Okay, guys? I'm just here explaining one application why sometimes I need to measure time, right? Because this time, actually, I'm gonna plug it in here to get the distance, right? And there are many other applications, something like that, but I just give you one application, okay? Any question, guys? Okay, so what I'm saying here, guys, sometimes in many application, we need to measure distance, right? Either it can be a distance, something like as you see here, or it can be something from here to here, or it can be actually difference between two signals, because this difference again can tell you something. So you take this one, use it to measure something similar to what I did here when I calculated t, right? So how can we measure? How can you measure this time? This is a question now. How can you measure this time, right? So the way you are going to do it is using input capture, right? I'm going to tell you how. So input capture, maybe you can use other ways, but input capture can make it very easy, very simple, okay? So let me say here, input capture, I see input capture only can use when you want to measure time. Period, big period here, okay? So every time there is an application and you want to measure a time for a signal this way, input capture. This is why they made input capture, okay? But how this can measure time, right? I'm going to tell you how as well, right? So the idea is, look here, guys, you are going to take one channel, and this channel, I told you can program it as input capture, right? And then you can connect the signal here. So the signal, you have to connect it here, right? And all what I need to do, I want to measure the time from here to here, right? That's what I want to do. So there is a pin to this channel, and then you can connect it to the signal, and then you can measure the time here, okay? So this is this one thing. So another thing is, so how can you measure? How can you measure this time? The idea is we have a counter. So the counter is going to help me. Counter. Now you are going to understand why you have something that is running all the time, counting all the time, right? I'm going to tell you how. Look here, guys. The counter, as you see here, once a rising edge comes here, right? I need to know what was the count here. For example, the count here was I was at count number 7, for example, right? And then here, also, I need to know what was the count here. For example, the count here was, for example, 70. Okay. So when the rising edge came, this was at the count 7. When the falling edge came, I was at the count 17. That means from here to here, the timer counted 10 times. 10 times, right? That's all what I need. If you know you counted 10 times, 10 counts, right? And you already know how much is the time for each count, right? Which is 1/f, as I said before, you can easily convert the number of counts to time. You got it? So that's exactly what happens in input capture, okay? So what happens in input capture, guys, is every time a signal comes, something like that, this one is going to trigger interrupt. This one is going to trigger interrupt. And in the interrupt subroutine, you have to take the count. You have to take the count, and then you have to use, you have to take this count, and then you have to wait for the second one to come. And then when the second one come, also there is another interrupt. And at this interrupt, you have also to take the second count here, and then you have to do the calculation, right? Okay, let me summarize what I said about input capture. Again, this is just a big picture. I'm going to give you details, but let me give you a big picture. Again, the timer system, right, is very interesting, very important, because it can help me to do something very difficult. If I do it without timer system, it would be somehow very difficult, right? Somehow, or it's gonna take too much time, whatever. But this one is gonna do it easily, very easy, very efficient. Why it is very easy? It's just two interrupts, man. Right? It's very easy. Just two interrupts. One interrupt, you're gonna get a number. In the other interrupt, you're gonna get another number, and then you can do the calculation. And microprocessor is free all the time. Microprocessor is free all the time, right? So all what I need a very little time for my microprocessor just to take two numbers, right? Other than that, microcontroller is free, right? Can do anything else. Microcontroller is not gonna check. It's not gonna check if this pin is 1 or 0, whatever. Okay, so summary, input capture is used if you want to measure time. And I told you there are many applications that is used to measure time. Okay, also I explained how this counter is used to help input capture to measure time, because all what I need to know what was the count here and what was the count here. That's it. So, and then I see how many times or how many counts. So during this time period from here to here, okay, the counter counted how many times. Once you know this, once you know how many counts, you just multiply it by time, and then you can transfer it to time. This is input capture. I'm going to give you details for sure. That is why input capture has interrupts. I told you input capture has interrupts. It has interrupts because I told you we need to have interrupt here and we need to have another interrupt here, right, guys? Any question before I move to output compare? Any questions? Is that clear? Great. Big picture, I'm going to give you more details. Now, also, I told you every channel can also act as output compare. Output compare. Okay. So let me tell you how this one is useful. Okay. So this one is used if you want to generate a square wave. If you want to generate a square wave, something like this one, or something like this one, or something like this one, right? So if you want to generate a square wave this way, right, you can use output compare for that. Okay, guys. So how in many application we need to generate square waves, right? Many application. So how is this different from what we did in chapter 3? I'm going to tell you how. Chapter 3, if you remember, when we did the flashing LED, we generated square wave, right? And we had a lab. We had a lab to do that, right? But this idea was terrible. Yeah, this idea was bad. Why? Can anyone guess why this idea was bad? It was bad because microprocessor was busy all the time. Microprocessor has to count here, has to count here. So microprocessor cannot do anything else, and that's bad, right? We want to make a big application, right? So I don't any task. If one task takes too much time from microprocessors, it's bad, right? Because I have other tasks. If you want to make a big application, right? So the idea we did before was not good because here, if you remember what we did, we set the bin and then delay. You remember delay YMS, and then we clear the bin and then delay YMS and then go back, right? So the microprocessor was busy all the time. That's too bad, right? So now output compare is gonna solve this problem. Output compare is gonna solve this problem. How? Output compare is gonna generate this square wave efficiently. And when I say efficiently, I mean we are gonna take much less time from the microprocessor. That's what I mean. Okay. How this will do it? I'm gonna tell you how. Look here, guys. What's gonna happen is that here Okay. At this point here, you're gonna have interrupt here, and also you're gonna have interrupt here. You have interrupt here, and you have interrupt here. Okay. So once I come to this point here in this interrupt subroutine, I'm gonna say to output compare. For example, if the timer now at 7, right, and I need to know what is the time here, I have to convert this time to number of counts, right? So I have to divide this time by 1 over f. 1 over f is the time for one count, right? So I have to convert this time to number of counts. For example, from here to here, the counter should count, for example, 100 times, right? So and from here to here, I have to do the same thing again. So from here to here, I'm gonna say, for example, it's gonna be 200 counts. So you have to convert the time to number of counts, right? And then once I come here, I'm gonna tell the output compare, please output compare toggle the bin after 100 count. Okay, that's it. You have to say that in the subroutine, and everything is gonna be done automatically. So if the count now is 7, output compare is gonna wait until 107 after 100 count to do this toggle. Is that okay? Once you come here, you are once this toggle is done, also you are gonna trigger interrupt. In this interrupt, this time I'm gonna say, please, next toggle is after 200, right? So that means if the current count now is 107, I'm gonna say, please, the next toggle should be after 307, right? At 307, please toggle, right? That's how it is. So let me tell you the conclusion before. Again, all of that just big picture. I'm going to give you the details right now. So, and again, that is also you should understand from what I said. Number one, why output compare needs interrupts, right? Output compare needs interrupts because in every interrupt, as you see here, guys, I'm going to say how long this one has to stay before you toggle it, or how long the 0 should continue until you toggle it, right? So in every interrupt, you have to say you have to put some value, or you have to determine this value, right? So if you see, we are doing something very interesting, guys. That means all what you need to generate a square wave, all what you need from the microcontroller is just very little time, right? The time here, right? The time in the subroutine, right? So very little time comparing to what we did before, right? This is true, but this is because most of the work is done by external circuit, right? Someone has to do the work anyway. Someone has to do the work, right? So if the microswitch doesn't do it, the external circuit has to do it. That's true. So the external circuit is gonna count for the time, right? And it's gonna toggle the pin and interrupt you again in order to set the new count. How the new toggle after one, how many count it is toggle. So now you can understand why output compare has interrupts. Also, you should understand why you need the counter here, why the counter is used here, right? Because this time here is going to be measured in number of counts. Is that okay, guys? Is that clear? Conclusion: output compare is used if you want to generate a square wave efficiently, right? And we use a timer here. All what you have to do, guys, we have interrupt here, we have interrupt here, and you have interrupt here, we have interrupt here. So every time the signal changes from high to low or low to high, you have one interrupt, right? All what you have to see here, you have to say how long time the signal has to stay here in order to toggle after this time. Okay, this is what output compare is. Conclusion: input capture, guys, it is used input capture if you want to measure time efficiently, and I already explained why you have interrupts, and also why we need the counter. Same thing for output compare here as well. Okay, but output compare is used also output compare is used if you want to generate a square wave on a pin. That's why output compare has a pin, right? You can see now the pin here is different from the way we used the pin here. The pin here is used to generate signal, but the pin here in input capture is used to receive a signal. Okay, guys. Now I'm going to give you the details. Any question, guys? Okay. As I told you, nothing is new. This is a good thing, right? Nothing is new. We are going to trigger we are going to program interrupt similar to what we did before. Same thing, right? You have enable bit, you have interrupt flag bit. Everything is the same, right? So that's why I'm saying these advanced topics, it's easy to learn them if you already understand what we did until chapter 4. Okay. So let's now give you the details. Let me first explain input capture here again quickly. So I told you guys we have timer, we have sorry, counter, this counter or timer, whatever you want to call it, right? So this counter or timer, it has there is something called TCNT, as you see here, TCNT. This is the name of the register. So if you want to read what is the value of the timer, this should be stored in TCNT. So TCNT actually is going to give you the current value of the timer, right? The counter, right? So this is the value that's increasing, okay? So this is the name of the register, TCNT, okay? Also, every channel has a register, 16-bit register, we call it TC, right? So here, we have here TC0, TC1, TC2, TC3, and so on. I'm going to tell you how we use it. So every channel has one register, 16-bit, okay? So let me explain how input capture works. As I said, guys, input capture works this way. Once there is um, rising edge or falling edge, this is something, as I'm going to explain later, this is something you can program. So every time we have a pin, you connect this signal to a pin. When there is a rising edge, right, the input capture automatically is going to take the current value of the time of the counter, is going to store it in this register TC, the number of channels. For example, if you use channel 3, so it's going to be TC3 this way, right? And then it's going to trigger interrupt. In the interrupt subroutine, you have to take this value from here and you have to store it somewhere, right? Because I told you all what I need one value here and I need one value here. Once I do that, I'm going to do the calculations, right? So here, so very easy. You don't need to do anything. Just when you go to the subroutine, you will find the number of the count. The count is already stored in this register. Just take it to store it somewhere. That's it. Otherwise, if you don't do that, it's going to be next time when there is falling, is going to be overwritten. It's going to be overwritten. So you have to take it and store it in a memory location. That's it. And next time, for the second one here, yeah, for when this one comes, I'm gonna do the same thing, and then once I have the count here and I have the count here, I can do the calculation. Summary: the input capture, guys, it works this way. Every time there is rising or falling, I'm gonna explain later. This is something you can program. You can capture only rising. You can capture only falling. You can capture both rising and falling. Right? This is somehow different from IRQ, right? In IRQ, I had only chance to capture only rising, only falling, right? But now you can capture only rising, you can capture only falling, you can capture both, as you will see right now. Okay, so and then you are gonna have one interrupt here, and then we're gonna have one interrupt here. Okay, so once this signal comes on the pin, once rising comes on the pin, the value of the timer is going to be stored in one register, and then you go to the interrupt and take it. That's it. Very easy, very easy, very easy. Okay, guys, any questions? Okay, so yeah, that's what I explained. This if you want to measure the time difference from here to here. This is also if you want to measure the time from here to here, as I explained. Now let's talk about output compare, right? Output compare, I told you we have a pin, right? Now I want to generate a signal, not measure time. No, generate a signal. So you can program this pin, right? I can tell the pin you have to toggle. So every time I told you, for example, if I program it to toggle, okay, you can program to do another thing. So what's that so-called action? So you can program action to be taken on the pin. For now, I'm going to give you details later, but the action can be actually, I want the pin to be 0, I want the pin to be 1, I want to toggle it. For now, let's focus on toggle before I give you more details. Okay, what is the idea? As I told you right now, if you want to, yes, let's see this example. Very, very good example. Look here, guys. I want to generate a signal like this one, as you see here. I want to generate a signal like this one. I told you we're going to have one interrupt here and one interrupt here, right? And one interrupt here and one interrupt here. Okay, look here, guys. The first thing you have to do, you have to convert the time. This time you have to convert it to number of counts, right? So now I want to, this should be 300 microsecond, right? And I know that clock 1 over f, okay, should be yeah, this is the time for one count is 1 over 3 microsecond. Okay, so the timer should count incremented by 1 every 1 over 1/3 microsecond, right? So all what I have to do, guys, I'm going to divide 300 microsecond, I'm going to divide it by the count, by the time of one count, right? and then I will find the result is 900, as you see here. That means from here to here, the counter should count 900. And from here to here, I'm going to do the same thing, but on 700. So the counter is going to count 2100 counts, or 2100 counts. Is that okay? So this is the first thing you have to do. The first thing you have to do, you have to divide this time, guys, by the time of 1 clock in order to get how many counts here and how many counts here. Okay. And then after that, okay, so at this point in this interrupt here, I'm going to say TC0. TC0, I told you every register should have, every channel has one register TC, right? I'm going to say TC0 should equal TC in T. TC in T actually is the current count, right? Plus 900, That means I am saying, please output compare toggle after 900 counts. Did you see what I did it? Yeah, how I did it? So if TC in T is here, TC in T, the current count is here, right? So I need to add 900 to see what should be the count, okay? And then I have to put this one in TC0, right? So the timer is going to count. Once it is equal to TC0, two things should happen, as you see in this figure here. Look here, guys. So I have to put some value here in TC0 or TC30, whatever any channel you are using. And then this should be a value in the future. So if the TC, if the TC in T is here, after 900, I'm going to take this value, put it here, right? And then this one is going to count. And then after 900, right? Once, as you see here in this figure, once the value of the counter, right, TC in T is equal to TC3, once they are equal, two things should happen. Number one, interrupt is triggered. Number two, action will be taken. And this action, something you can program. For example, if you select toggle, so it's going to be toggle, right? That's exactly what I have to do here. So if you want to generate this signal, guys, all what you have to do, as I told you, have interrupt here. In this interrupt, I'm going to write this one here. Right? I'm going to say, please, output compare, please. Next interrupt after 900 counts, right? So count 900 and then toggle after that, right? Here, but here in this interrupt, I have to write this one, right? So, and this has to be done periodically. So all the time, same thing, this one is here, same thing, this one is here, and so on, right? So that means I need to say after 900 counts, please toggle, and also it's going to trigger interrupt automatically. Okay. So that's how output compare. Very, very, very interesting. Why? Because I can generate a square wave, and all what I need from microprocessor is just very little time, because the subroutine is very simple. So this subroutine is gonna just put this value or this value. Very simple subroutine. So you're not gonna take too much time from the microprocessor. Again, this is because microprocessor is not gonna count by itself. Similar to what we did in chapter 3, similar to what delay YMS did. In delay YMS, microprocessor had to count, right? Had to execute some instructions to count for 1 second, but now we don't do those. Someone else will do it, right? So that I want to free the microprocessor so that it can do something else, can do another task. Okay. Any question, guys? Great. Now I'm going to talk about programming. And again, the good thing is you're not going to see big difference. Actually, there is no difference between the way we programmed RTI and IRQ and between the programming I'm going to do right now. You will see. Just we change the name of the register. So let's start with programming the timer. How can you program the timer? Okay. To program the timer, or to program any channel, similar to what we did in IRQ and RTI, guys, you have to tell microprocessor where is the interrupt subroutine, right? That's it. Similar to what we did in RTI and IRQ. So you have to do something org like this one, right? So if you want to program the timer overflow, you have to use this value. When we programmed IRQ, I used this value. When I programmed RTI, I'm going to use this value. When you program timer channels, you have to use this value. So again, this slide, nothing is new in this slide. I just similar to what we did in IRQ and RTI, but just you have to use this number here. Okay, guys, this number one, you have to do it. For any interrupt, you have to do this, right? Okay, This number one. Number two, now we have again here I'm focusing on programming the timer. After that I'm gonna explain how can you program input capture and output compare channels. But let me finish the timer first. Okay. Number two, in this register TSCR2, this register, right? I told you I explained this part here for the prescale. Remember this prescale you can control the speed of counting. So the input here is 24 megahertz divided by the prescale, right? So by changing the prescale, you can change this frequency here, and then you can control the speed of the counting, because for every cycle, the counter is going to increment it by 1, right? So you have to put here some value based on how much, based on the value prescale do you need, right? So 0 is going to make 1. The maximum, the maximum you can make 128 here. This is the maximum value you can put for prescale, right? This is for this part. Number two, any interrupt. That's why I'm telling you guys, nothing is new. For any interrupt, I have to tell you two things. As I mentioned before, for any interrupt, tell me where is the enable bit, right? Interrupt enable bit, and tell me where is the flag bit, interrupt flag bit. Remember, the flag bit is the one you have to clear, right? So here for the timer, because the timer is generating interrupts, right? So it should have any source of interrupt should have enable bit and also should have interrupt flag bit. So here for the timer, it has this bit here in this register, bit number 7 in this register here. This is one should be enable or disable interrupts, overflow interrupts, right? Remember I said for the timer we have overflow interrupts. So you can enable or disable these interrupts, right? Until now I didn't explain yet why I need the overflows here. I'm gonna explain later. Don't worry. Okay. So why I need to interrupt here? So actually, if you go back here in the very beginning, I told you input. We have one interrupt from every channel, right? And I already explained why we need this interrupt for input capture and why we need it for output compare, right? But also I told you we have another interrupt here that can come from the counter, but I didn't say yet why you need it. So I'm gonna explain it. Okay. So this bit here is can be used if you want to enable or disable interrupts. Okay. We have another pin here, guys, in this register DSCR1. Is that right? Yeah, this is 2 and this is 1. We have another register DSCR1, right? The last one here, guys. This one is used if you wanna if you wanna run the timer counting or no counting, right? So do you wanna don't be sometimes some students are confused between this one and this one, right? This one can control. Do you want to trigger the timer is counting, but when the timer rules from 111 to 0000, do you want to trigger interrupt or not? That's it. So this one is different. This one, do you want the timer to count or not, right? So if I put 0, you actually disable the timer, so the timer is not counting. Okay. And usually this is done if you want to save power consumption. If you power your system using battery and you don't need to use the timer, so why I consume the battery and run the timer all the time, right? If I don't need it, right? So if here I put 0, that means the timer is not going to count, right? If I put 1, it's going to be count, right? So this is another bit I want to tell you about. The second bit, interrupt flag bit, right? So you also have to tell me where is the interrupt flag bit. Interrupt flag bit is this. It is bit number 7 in this register, TFLG2 in this register, and bit number 7. And again, as I explained before, in the interrupt subroutine, you have to clear this bit. As I explained in before. The only exception, as I said before, IRQ. This bit is automatically cleared, right? But for RTI, you have to write an instruction to clear it. Same thing here. You have to write this instruction to clear this bit. Once you serve the interrupt, that's why this one has to be in the interrupt subroutine. Okay. So this is just a diagram I'm explaining here. Here, this is 24 megahertz. So just in this picture, I put everything together. This 24 megahertz this way, right? And this is the pin I told you to run or don't run. If you put here 0, so the output here is 0. Okay, this will be the input of the counter, because the counter should count as long as there are clock, right? If there is no clock, the counter is not going to count, right? So if you put 0 here, we are going to get 0 here because of this end, right? However, if I put 1 here, I'm going to get the signal here. This signal is going to come to here, right? Once you have this signal, I'm going to divide it by prescale, and then I'm going to input it to the counter, right? And then the counter here, every time the counter overflows, is going to actually put 1 here in the flag bit, right? Also, if you enable interrupts and the flag bit is 1, and also you enable the global interrupts, now this one should be 1 to trigger interrupts. So now there are three conditions. The local bit should be enabled, the global bit for interrupt should be enabled, and there is interrupt request here. If all of them, right? But the only difference, this one should be 0. 0 means it is enabled, as I said before. That's why you have a bubble here to toggle it. Anyway, so nothing here is new. The good thing about this slide, I just put everything together, right? Here I just put the summary. If you want to program the timer, right? The timer interrupt, that's what you have to do. So you have to put this one here. You have to program enable timer, your TSCR1, as I said, TSCR2, as I mentioned before, and this is the interrupt subroutine. You have to use the same name here. As I did in RTI and IRQ as well. Believe me, nothing is new. You just manipulate some registers, and the way you program the interrupt is similar to what we did before. Okay. Also, you have to clear the flag bit this way. Okay. This is if you wanna program the timer interrupts. Okay, guys. Now, what if I want to use the timer, but I don't need to use the overflow interrupts? I disable the overflow interrupts. Very easy. So in this case, number one, I don't need this one because I'm not gonna have interrupts. Also, I'm not gonna have this one because I don't have interrupts. Also, you have to change this one here, this 8, you have to change it to 0 to disable interrupts. So now the timer is running, but there are no overflow interrupts, just running without overflow interrupts. Anyway, this is just a summary. Very easy, right, guys? Any question? Very, very easy. It's similar to what we did in RTI and IRQ. You just trigger, you program the interrupt. Also, there are some registers, you just manipulate this register. Now let's go to input capture and output compare. Okay, I told you we have 80 channels, guys. Every channel can be programmed either input capture or output compare. You can program it and you can change it if you want, so at any time, but at a certain time only one thing can be done at a time. Okay, so number one, for any interrupt, you have to do this one for any interrupt, as I said, right? So, but now you have to use a number from here. So if you want to program timer 0, guys, you have to use this one. If you want to program timer 1, you have to use this one, and so on, right? Very easy, right? Now, I told you every channel.
Wait.
Yes. Yeah, sure.
So that one is, I'm pretty sure it's opposite because it says it. So this is if we were to do channel 7.
Yeah, here for channel 7. That's why I used this number, right? Look here.
Okay. Program channel 7. Okay.
Yes.
All right, I was just making sure.
Yes. Thanks. So if you want to program channel 0, I would use this one for channel 0. I take this one, put it here, right? And for sure, this is just a name. It doesn't matter what is the name, but usually, if it's channel 0, it makes sense to call it channel 0, right? If you want to program channel 3, just to put this number here. Yes, here I'm giving you example on channel 7. That's why I use this number. Yes. Now, I told you every channel you can program it to act as input capture or output compare. How can we do that? Very easy, very simple, very easy. Look here, guys. We have a register, as you see here. This is a register, right? This register has 1 bit for every channel. So this is 1 bit for channel 0, channel 1, channel 2, until channel 7. So every channel has 1 bit. Very easy, right? And then if you put 0 in this bit, you're asking, or you want to program this channel as input capture. If you put 1, you actually program this channel as output compare. Very, very trivial, very easy, right? So you have just a register. This register is called TIOS. Okay, this is for channel 4. If you wanna it to be input capture, just put 0. If you wanna make it output compare, just put 1. Very easy, right? So you can use move instruction. You can use bit set, bit clear, as I explained before. Any question? Very easy, very, very easy, right? So every channel has 1 bit. Every channel has 1 bit, and then by the value you put here in this bit, 0 or 1, you can actually you can actually program the channel input or output compare. Okay, again, this is initialization. It should be done only one time at the beginning of the program. That's it. Similar to the initialization we did in IRQ, similar to the initialization we did in RTI, one time at the beginning of the program, and that's it, right? Next one. As long as we have interrupts, please tell me where is the enable bits. Please tell me where is the flag bit, right? That's why I'm telling all of them are the same, right? So here for the enable bit, right? If you want to enable or disable input one channel, again, we put all of them in one register, as you see here. So we have tie. So we have this register tie, right? In this register tie, every bit here is going to be for one channel. So channel 0, channel 1, channel 2, and so on, right? And then every bit here is used to enable or disable interrupts from this channel, from the corresponding channel, right? So if you put here 0, you actually disable interrupts. If you put 1, you actually enable interrupts, right? Again, you can use move or you can use bit set or bit clear and so on. Okay, any question, guys?
I got a question.
Sure, go ahead.
I'm probably missed it in when you mentioned it the first time in the lecture, but what was the purpose of using? I just didn't want to write in my notes. What's the purpose of using input, the output compare in the input capture? That's what it's capturing. Like, what's the sole purpose of it? Yeah.
Input capture is used if you have a signal and you want to measure time. For example, I want to measure the time from here to here, or I want to measure the time from here to here. So if you have a signal and you want to measure the time, that's what input capture is used for. Okay. Output compare is used if you have a bin and you want to generate a score wave, right? Efficiently, right? Efficiently means you are going to take a little time from the microprocessor. Okay.
Okay.
Anyway, I'm gonna post the lecture. I explained it in details. I explained it in details in the beginning of this lecture. So just after I post the lecture, just watch it. And if you still have any question, let me know. Okay, man.
Okay.
Thanks.
Thank you.
The next one here. Yeah, another question. Great. The next one here, interrupt flag bit. Again, for any interrupt, you have to tell me where is the flag bit, because I have to clear this bit in the interrupt subroutine. Again, they put all the channels in one register. This is the name of this register, TFLG1, as you see here, and every channel has one bit. So every channel has one bit, interrupt flag bit, as you see here. Okay, and then as you know, if one channel wanna trigger interrupt, it has to put one here, right? And then if you wanna, so as you see here, if it is one, that means interrupt has occurred or triggered interrupt. And now in the interrupt subroutine, you have to write an instruction to clear it, right? So, and when you write an instruction to clear it, actually I don't know why they made it this way. I have no explanation, but as we did before, the way you have to clear it by writing one. Once you write one, it's going to be cleared. But anyway, so you can write something like that, okay, to clear it. Very interesting, very easy. Okay, so what's left here? Only two things are left here. Look, guys, what is left here? The next thing here is, let's talk about, this one is for input capture. If input capture, I told you guys, for input capture, we have a pin and we want to capture the time, right? So I want to capture the time. So similar to IRQ, you remember IRQ, there was initialization, and you can capture falling edge, or you can capture low level, 0 level, right? So these were the two options I had in IRQ, right? Now I have a different options here to capture, right? So you can capture only rising. So if I capture only rising, so actually I'm going to measure the time from here to here, right? You can capture rising, only falling, right? You can capture both rising or falling, right? So how can you do that? I'm gonna tell you how. So let me say it again. How can you program the input capture, right, to capture rising or falling or both? How can you do that? Okay, what do you mean by capture? I mean, if I program it to capture rising, that means I'm saying when the capture comes, when the rising comes, please do two things. Trigger interrupt, right? Number two, you have to store the count. This number one. Number two, store the count in TC0, TC1, and so on, right? This is if I capture the rising. That means if full comes, nothing will happen, right? Because I'm not capturing full, unless you are capturing full, right? So the full. Anyway, so I'm explaining now how can you do that. Very simple. So the way you are gonna do it, guys, here, every channel should have four choices, as you see here. If you put 0, 1, that means you want to capture rising only. You want 1, 0, you can capture only falling. 1, 1, you can capture both. 0, 0, you capture disabled. You're not going to capture anything. Okay, guys? So every channel needs 2 bits, as you see here, because we have 4 choices. We have 4 choices. That means every channel needs 2 bits. So total for the 80 channels, I need 16 bits. Okay, and that's what we did. That's why you will put them in 2 different registers. That's why you see here, guys, we are going to use two different registers, TCTL3 and TCTL4, right? So total, they are 16-bit. Why? Because every channel should have 2 bits, right? So very easy. So these 2 bits are for channel 0. These 2 bits are for channel 1, channel 2, channel 3, channel 4, channel 5, channel 6, channel 7. Okay, guys? So every channel should have 2 bits. And then, based on the number you are going to write in these 2 bits, you can capture only rising, only falling. You can capture both. Is that okay, guys? Great. Any questions? Great. Now, the last thing is I'm gonna explain right now. As I told you guys, this is for output compare, only output compare. Okay. So for output compare, guys, here I'm gonna say after 900 counts, okay, please take action on the pin. Okay, what do you mean by action? Okay, I only focused on toggle, right? So action, actually, it can be again, what happens here in this interrupt, I'm gonna put a number in the future, right? The count in the future, and then I'm gonna say once TCNT, which is the counter, is equal to this future value, please trigger interrupt, and also take action on the pin. So what do you mean by action? When I explained it before, I just focused on toggle, but actually it is more than one toggle. So action can be, as you see here, guys, you can toggle. So that means after this time, you can toggle the pin. If it is high, you make it low. If low, you can make it low. Or you can clear it. That means, for example, if it is something like that, I'm going to say after a certain time, if it is high, sorry, I'm going to say after a certain time, please make it low. You got what I'm saying? So you can clear. So this is action. Or you can make sit. So the action means once the value in TC is equal to CNT, please sit the pin. Okay? That's why, if you see here, guys, we have 4 options as well. We have 4 options here, right? Again, this is only used for output compare. Okay, guys? We have 4 options. Okay? So what do you want to do on the pin? What do you want to do on the pin? Okay, in the future, you say after 900 counts, please toggle the pin. Please clear the pin. Please set the pin. So it's something you can program, right? Again, similar to what we did right now for input capture, also because we have 4 choices, so that means we should have 2 bits, right? For every channel. So total, we should have 16. We need 16 bits, right? That's why we're going to use 2 registers, TCTL1 and TCTL2, as you see here, okay? So these 2 registers to program the action you want to take on the pin for channel 0, channel 1, channel 2, channel 3, 4, 5, 6, 7. Okay, guys? And for every channel, you can put the value, whatever you want to do. What do you want to do? Okay? You want to toggle, you want to clear, you want to set. Depends on how you are going to generate the signal. And I'm going to give you example later. Any question, guys? Okay. I summarize what I explained just here. Okay, guys? If you want to program input capture, guys, for sure you have to use this one. For any interrupt, you have to use this one, right? And here I'm explaining channel 0 here, right? So also you have to clear it this way, as you see here, because it's channel 0. Don't be confused, right? Here I give example on channel 0, okay? So if you want to use another channel, so you have to use different number. So this number has to change, right? This number also has to change because here I have to put 1 in the first bit because it's channel 0, right? If it's channel 1, so the 1 has to be here, right? So also Again, if you wanna use input capture or output compare, you have to make sure the timer is running, right? It's very serious, because if the timer is not working, input capture output compare is not gonna work. They are not gonna work, right? So because input capture and output compare need the timer, right? So you have to make sure the timer is running. So that's why I put this one here in the main program. So this part, you have to write this part in the main program. One time should be enough. Also, you have to program TIOS, as I explained before, to make it input capture, not output compare. You have also to program TCTL4 if you want to capture rising only or falling or whatever. Here I made it for only rising. Also, you have to enable interrupts. Okay, so nothing is new, just I summarize what I explained before. For output compare, they are exactly the same thing. So this one is exactly the same, no difference. This one is exactly the same, no difference, right? And also this one also the same, no difference, right? This one is the same, no difference. So the only difference will be in these two. Only difference will be in these two. Here, because this one here I used 1, here I used 0. Sorry, here this one was bit clear, the other one was bit set, right? Because if you clear, you make it input capture. If you set, you make it output compare. So this is the only difference here. Also, here I have to initialize what you are going to capture, rising, falling, whatever. Okay, but here we don't have rising, falling. Here what you have to initialize here is the action. Action has to be taken on the pin in case of output compare, right? That's why here you have to use this register TCTL2. Here I used 4. That's it. So everything is the same if it is input capture, output compare. Only these two instructions are different. Any question, guys? Great. Okay, now, so how can I explain? You explained in how can we do it in assembly. What about C? How can I do it in C language, right? In C language, we have just a number of functions similar to what I did before. You can just use these functions, just a set of functions. So number one, for example, you have a channel 0 enable. If you want to enable a channel 0 or any channel, you have channel 0 disable. If you want to disable any channel, right? You have also a channel 0 clear flag, or channel 7 clear flag. If you want to clear the flag bit, right? Also here, for the timer, we have this one, timer run. So this one actually is gonna run the timer. I told you there is one bit in TC SCR1. This one, if you want it count or not, right? Timer stop. This one is used if you wanna stop the counter, so the counter is not counting. And these two for enable or disable. Okay. And this one is used for to initialize the timer. So the number you have to put here, right? This is the prescale number, right? So let me explain what this function is going to do. A lot of things. Number one, this one is going to set bit number 7 of TSCR high. This one here for counting, so to count. Number two, this one is gonna clear the counter. So because we wanna start from 0, right? So this one is gonna put 0 in this register to clear the counter, right? Also, this one is gonna set bit number 7 of this one to high to enable interrupts. Okay. Also, the value you put here, this value, I'm gonna take it, and 2 to the power of this value, you are gonna get the prescale. So actually, this value is similar. Let me go to the timer. Yeah, it's similar to the value you put here. Look here, guys. Yeah, similar to the value you put here, which is a value from 0 to 7, right? But actually, the actual prescale should be 2 to the power of this value, right? That's why here we start from 2 to the power 0 until 2 to the power 7 here. Oh, is that okay? Again, so this is what you have to send. You have to send to this function. Very easy, very trivial. You just send some value to the function, similar to what we did before. Okay. Also, in the interrupt subroutine, you have to clear the flag bit this way. Is that okay? Also, you have you also have one function here if you want to reset the count, right? So this one is going to put 0 in TCNT if you want to reset the count. Okay. For a channel, we have channel 0 initialization, 1 until 7, right? So here for a channel, all what you have to do here, you have to send 2 values, as you will see right now. One value, which is P here, B is used. This one is going to go to TIOS to make it input capture or output compare. That means, very simple, that means if I put here 0, I'm gonna make it input capture, right? If I put 1, I'm gonna make it output compare. This is what about this one, okay? Also, this function is gonna enable interrupts from tie. It's gonna enable interrupts, okay? Also, whatever you put here, this one is gonna go to you know, we have some value to for capture. If you wanna set it, if you wanna for configuration, or you wanna capture rising only, falling, and so on. So this value actually, if you select, if you say again, the same function can be used for input capture or output compare, right? As I said, the only difference will be just the second argument, right? So the same one here is used for input capture, output compare. The only difference you put here is 0 or 1, right? So 0 is going to make it input, 1 is going to make it output, okay? However, this one here, this one, if it is input capture, I'm going to take this value here. If it is input capture, so the value will send it, I'm going to use it here to select the cap, what do you want to capture, right? But if you select it to be output compare, so this value you are sending to me, I'm going to use it here, right? To program the action you want to take on the pin. Okay, guys, any questions? Again, so in C language, nothing is new, similar to what we did in RTI and IRQ. You have a set of functions. You can just use these functions, or you can just use the name of the register this way. Okay, so you can just use the name of the register to manipulate them this way if you want. Okay, or you can use the functions as, so you have two options now. Any question, guys? One more thing, in C language, you remember in C language, when you write the interrupt subroutine, you have to put void, you have to put interrupt, you remember, and then you have to put a number, right? You have to put a number, and then you have to put a name, right? Any name, right? Name. But number, this is the most important thing, is the number. This number should tell the C language what is this subroutine is for which interrupt. You got what I'm saying? So very easy, similar to what we did before. If you remember, we used number 6 for IRQ. For RTI, we used number 7. Nothing is new, guys. I'm just repeating what I did before. For timer 0, it's going to be 8. So you have to, if you are programming timer 0, you have to put here number 8. We did before 6 and 7. Now you can put 8, you can put 9, you can put 10, right? And so on. You can do for 14 here, and also you can do 15. For the timer overflow, is going to be 16, right? So this is what you have to do, right? Very easy, very interesting. Any question? Great. So now I am done. So let me explain what I did so far, guys. Number one, I explain we have timer system. I explain the architecture of this system, right? I explain how it works. I explained what is input capture, what's output compare. Also, I explain how can you program them. Now, I want to go for examples and applications, okay? So let's start with the first example here. I'm going to skip maybe this one. Or let me explain it, that's okay. Look here, guys. The first application I want to teach right now is, okay, let me go to the, oh my goodness, okay, let me come here. Look here, guys. I'm going to tell you something very interesting. You will like it, coach. I'm sure you will like it. Look here, guys. If this is a microcontroller, right, and we have here one pin, for example, when you had IRQ. What is IRQ? Very simple. IRQ means every time there is a falling edge, guys, I want to trigger interrupt and execute a subroutine. That's what IRQ means, right? Okay. Now, I want to make analogy. I want to make analogy between IRQ and input capture. You will be surprised right now. You will find there are overlap between IRQ and input capture, right? So what is input capture? Input capture, every time there is like rising, falling, whatever you program it. For example, I'm going to program it for rising, for falling, whatever it is. So it can be rising, it can be falling, it can be both. So whatever is the way you program it, it doesn't matter. So every time there is an event here, for example, rising, okay. Number one, interrupt is triggered. This number one. Number two, right? TC in T is stored in TC. This is the time of this event, okay, or the count of this event, okay. If you look at IRQ and you look to input capture, they're the same. Every time there is an event, an interrupt is executed. Every time there is an event, an interrupt is executed. Is that okay? So I can say input capture can do the same job or the same task as IRQ, right? But input capture is going to do one more thing, which is this one. I can just ignore it. I don't care about it. I can just ignore it. You got what I'm saying? So now I wanted to say something very interesting. Now I told you input capture is used if you want to measure time. Yeah, that's true. If you want to measure time, use input capture. I want to add something to it. I want to add something now. Also, input capture can be used like IRQ. Yes, as you see here. So now I don't care about the count. I don't care about the time. I only care all what you need to do similar to IRQ. Every time there is a rising, if there is falling, okay, I want to trigger interrupt, okay. I like input capture even more than IRQ. You know why I like it more? Because it gives us flexibility. IRQ can only capture falling, right? Input capture can capture or can trigger interrupt when there is a rising, falling, or both, right? Is that clear, guys? The idea is clear. That means this is a very interesting thing, very, very interesting. That means now you can say we have 9 IRQs. Wow, right? So now you can say you have up to 9 IRQs, okay? The IRQ I explained before, and we have 8 input capture. If you want, you can use all of them like IRQs. Very interesting, right? That's why you can make big applications. That's what you should understand. Microcontroller can run big system, right? Or big application. Not very simple. It's not simple, okay? So that's why. Okay, guys, very interesting. So now I'm going to explain in this program. I'm going to explain how can you do that, and very simple. Okay, so actually, I'm going to use the same code here. Look here, guys. I'm going to use the same code. Nothing is different. I'm going to use exactly the same code I explained here. The only thing here, guys. I'm going to use exactly the same code here, guys. Nothing is different. The only difference is, usually if you want to measure time, usually you have TC0, for example, or here I'm using channel 0. So here, usually here I care about TC0, so I have to store it somewhere because I'm measuring time, right? I don't want to be overwritten, so I need the count here, okay? The only difference is, so everything is exactly the same. The only difference is I don't care about TC0, right? So I'm not going to use it because I'm not measuring time. All what I need, just every time there is a rising, I need interrupt. That's why very easy, very simple, right? So now, here I'm explaining this program here. So this is the first thing I'm explaining here. How can you use input capture like IRQ, right? So if you see here, guys, so here I want to make a rising edge every time I pressed. Okay, so here what I want to do, guys. Yeah. So a switch is connected to, so we have a switch every time I press a button, something like that. So here every time there is a rising edge, right? So I want to, there is one LED. So every time I press a button, I want to, if the LED is on, I'm gonna make it off. If it is off, I'm gonna make it on. You got what I'm saying? So every time I press a button, I'm gonna trigger interrupt this way on port T, right? So trigger interrupt, and then in the interrupt subroutine, I'm gonna toggle the LED, right? Very simple program. I'm gonna explain the idea. So here, number one, you have to use this one, guys, for to program the channel 0, right? Here nothing is new. This is just for port to program the LEDs. Nothing here is new. And then this is the exactly same thing I explained before. Also nothing is new here. And then this is the subroutine here. Look here, guys. This is exactly like IRQ, right? So number one, in the beginning, you have to write this one, right? You can put the debouncing code here if you want, right? And then here I'm doing something else here. Every time there is interrupt, if again, it depends on what you want to do. So every time you press a button, this subroutine is going to be called, right? So if I want to flip the LED, just flip the LED here. You can write the code. But here I'm not doing that. What I'm doing here, I increment a count. Okay. So and then move this count to port B. So actually here, it's like, as I explained before, this idea, I explained it on IRQ, but it's the same thing here. So I can use input capture 0. I can put here like infrared. Someone can cut the line. When you cut the line, you can actually generate a pulse to trigger interrupt. And now I can count a number of events. I can count it this way. Okay, very simple program. Again, and here in the interrupt subroutine, I'm not going to use TC to see because I'm not measuring time. Is that clear? Very easy, right? Any question? Same thing if you want to do it in C language, you guys here, right? In C language, again, nothing is new. This is the interrupt subroutine is here, guys. And most important thing, you have to use this number 8 because this is for channel 0. Also, don't forget to clear the flag bit, right? And then here, write whatever you want to write. Okay, so every time there is interrupt, every time there is rising or falling edge, what do you want to do, right? So you can just write whatever you want to write here. Okay. Also, in order to program or configure the interrupts, you have to use this function timer run. Also, you have to use this one. Okay, let me tell you what I did here. Look here, this number you have to put 0 here. Why? Because this 0 means I want to program channel 0 as input capture, right? So this is the meaning of this 0. This one, as I said before, this one means it should be number 1, which is if you go to the table, what I explained before. 1 is going to be for input capture because I want to capture the input capture, right? Sorry, I want a rising edge. I'm sorry. This is for rising edge. So you can put here. The number you put here. It can be used for rising edge, falling edge, right? Or it can be both. Okay, very easy, very trivial. Good news, guys. You are gonna have 9 IRQs. Very interesting thing. Okay, guys. Now, let's. So again, I didn't use it like I didn't use it as input capture. I just used it. What I mean here, I didn't use it to measure time, but I used it like IRQ. Okay. Now, which is interesting because we don't have too many IRQs. We have only one IRQ, right? So sometimes you may not need all the channels to measure time, right? So you can use one of them as input capture as IRQ. Okay. Now, also, again here I want to make analogy between RTI and output compare, and you will be surprised. Now you will see overlap as well, right? So look here for RTI. For RTI, I need periodic interrupts, right? So for example, I need periodic interrupts every some time, right? So output compare, it can be used to do the same thing. So because what happens, I told you, we have one interrupt here, right? And then I can say next interrupt after 900, right? Or whatever, 9,000, whatever, right? So also I can say next interrupt after 9,000 here in this interrupt as well. That means if you see how output compare works, you can trigger periodic interrupts as well. Very interesting. Very, very interesting. So output compare, so this is RTI. RTI is gonna generate periodic interrupts, right? Output compare also is gonna generate trigger interrupts, periodic interrupts. Plus, this one is gonna take action on the pin. So in addition to generating periodic interrupts, this one also is gonna take action. I don't care about the action. Okay, I don't care about the action. So that means, very interesting. That means I can use output compare as RTI. Very, 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 very interesting. I can use output compare. Output compare can be used as RTI. Very, very interesting, right? Because we have only one RTI. Now you can have up to 9 RTIs. Wow, great. You got what I'm saying? So now, but how can you do that? I'm gonna tell you how. But even similar to what I said about IRQ, I like output compare. I like it more than RTI. You know why? Remember, when I explained RTI, I told you I don't like RTI because it's not flexible. It's not flexible when you set the time. When you set the time, you have a table, you have to pick up from this table. I'm going to tell you something very, very interesting. The beauty of output compare right now. Look here. For output compare, guys, I'm going to say we have interrupt here, right? And then I'm going to say next interrupt, for example, after 900 counts, right? And then you can say next interrupt after 900 counts. That means I can set the time I can set the time by the number of counts, right? The time out. The time out, can you set it in the number of counts, right? And if you can, if the time of each count is 1/3 microsecond, look how it is beautiful, okay? If the time of each count in 1/3 microsecond, guys, that means you can look how it is fine grained. So I can increment this number. I can increment this number little bit by 1/3 microsecond, right? Very beautiful, fine grained. You can increase it very little bit, right? So you can have very accurate timer, much better than RTI. You got the point here. So the value you put here, it's very fine grained, because every count you add, every one you add here, you actually increment the time by only 1/3 microsecond. Is that okay? So just give me one. Yeah, we still have 1 minute. So now, okay. Where is it? I'm gonna explain this one next time. This one next some time. But periodic measures, okay. Where is it? When you can use it like RTI. I'm sorry, guys. Yeah, this one. Just quickly, just 1 minute. So again, here nothing is new, guys. This is the same program I taught before. You just program. Just give me 1 second. Nothing here is new, actually. So number one, you have to program. You have to program this one for output compare, guys. Okay, this is number one. Number two, TIOS, you have to program. So nothing here in programming is new. This is exactly the same thing I explained here. So let me go back here, guys. Just give me, sorry. Yeah. So actually, yes, here. So I can use everything I explained here, guys, right? The only difference is going to be here. So here, every time I'm going to say TC0 should equal TCNT plus count. For example, 900, 700. So every time you have to do that, right? So that means interrupt me after 900. Then in next interrupt me after 900. That's how can you make periodic interrupts like RTI. So I want to look at it. Yeah. So if you look here, so this is just initialization similar to what I did before. So if you look here, guys, what I did, you have to clear the flag bit. That's okay. And now this is the most important thing. Look here. I'm gonna read TCNT, right, which is the current count. So and then so here this is assembly. I'm gonna say TC5. Here I'm using channel 5 should equal TCNT plus what we call interrupt period, whatever it interrupt period here. Okay, a certain value. This interrupt period is here. I put 3,000. Okay, guys. So that means because I make it 3,000, that means I'm gonna make interrupts every 3,000 counts. And if the time for every count is 1/3 microsecond, if you program the counter to run with this speed, actually you are gonna trigger interrupts every 1,000 microsecond, right? If you multiply 3,000 counts by 1/3 microsecond, you are going to get 1,000 microsecond, which is 1 millisecond. Very easy. And if you need more interrupts, you can just change this number, right? But you remember, this one is this number cannot be more than 16-bit, 65, 535. This is a maximum. It cannot be more than that. Very interesting, very easy. Okay, guys? Very easy. So you can even change the time easily. So you can change, number one, you can have a very accurate time out, right? And you can, very accurate, and you can increase it by only 1/3 microsecond. Very interesting, right? And you can work with a certain speed. For example, I can say interrupt me every 1 millisecond, and then later I can change it easily. Here in the interrupt subroutine, I make it every 2 milliseconds, or I make it 3 milliseconds. Very easy to change it. Okay. Anyway, that's enough for today, guys. We had a very good lecture. So I'm gonna post this one. See you. Bye.